start on the biggest one first. Or 20?
20? Somebody agrees with you? Let's see.
And 18 as well. I got stuck on 18.
Okay. All right, let's start with 18. Let's see. Oh, yeah. Okay. So this is really how this chapter 1 through 6 review is going to work. I'm going to go based on what you ask me. I'm assuming you know all of it, right? So I'm telling you right now that assumption might be off. But I need you to ask questions about what you forgot, what you're having trouble with, whatever. If you don't ask questions, I'm going to get into the new stuff. So 18, solving systems of equations, stuff like this here. There were several different ways to do this.
Elimination.
Say again?
Elimination.
Yeah. There's one way you can do it.
Substitution, all that stuff.
Substitution,
Elimination.
all that stuff. Elimination, sure. You can do that.
Deja vu.
So one way, so what's substitution? Who remembers how substitution works?
We substitute instead of y, we solve for.
Yes, you can't just pick a value for x and y, because there's possibly only one value that makes both of these things work, one point that makes both of these work at the same time. That's what it means to solve a system of equations. Who remembers what this is graphically? If you solve this graphically, that's the method I didn't hear said.
Order pair?
Say again?
Order pair?
What's true about the ordered pair? It's the point that...
Both those intersect?
Lovely. So why the hell do we graph lines? So we have something for you guys to do. No. So that if I ask you, tell me all the answers to that equation, how long would it take you to list them? Tell me all the answers. It would take you for the rest of your life, and your kids' lives, and their kids' lives, and their kids' lives, and their kids' lives, and then that wouldn't be enough. You'd be nowhere near done. Because there's an infinite number of freaking answers to this damn thing. So stay with me for a second. One of the most fundamental reasons, not the only reason, but one of the most fundamental reasons we graph anything is to quickly answer what are the answers. If I graph the line, I say, well, the answers are everything that this line goes through. Leave me alone. I got shit to do. Right? Do you guys kind of understand? So it's a visual representation of all the answers to this equation. So if I graph both of these lines, the point they meet at is the point that works in both. That makes sense. I like it. So the answer to a system of equations will always be a point. And that point will be where these lines would meet. I like it. So, one way to do this, and I love looking at this like solving a murder, right? As if I've ever done that, but just, I've seen enough shows and shit, I'm sure I know something about it. You use all the information you have together to try to figure out stuff, like, was that guy really at this house, or could he have been over there? You try to piece together these clues, and you put them together, and then you see where it leads you. So I want to use both of these pieces of information. So like somebody said, for substitution, you would take the first one, for example, and you could solve for... Y. You can get y by itself. So how do you do that? What would that become? So if you solve for y, you gotta...
Subtract 5.
So you get y equals negative 5x minus 5. Is that cool? So then I know that is true. That is true. Bob was at this guy's house until 5 o'clock. Okay, great. I know that's true. I know it's true. I verified it. I know it's given to me that it's true. And then I have this other piece of information, and it's got y in it, but I know what the hell y is. I love so many guys like, oh, I know how to do this shit, man. I'm going to get everybody up to speed. So then I can use this. Instead of y here, I'm going to write negative x plus twice. Well, I know what y is.
Negative 5x.
Y is negative 5x minus 1. Become a 5. Well, that's closer. All right. And then you just have to solve that equation. It's only got one letter in it. One letter in it, so you can do it. You can solve it. That's the problem with both of these equations. They have two freaking letters. You can never solve it for a number. I can get it here. Ooh, that makes me feel good. I know what y is this. You don't know what y is? Shit. So then you plug it in here and I can solve for x. That's one way to do this. Is everybody cool with that? I mean, I'm not done. You solve for x and keep going. If we do this real quick, negative x minus 10x minus 10 equals 12. Is that cool? Bring the 2 through. And then you get
Negative.
negative 11x. If I add the 10, I get 22. If I divide by negative 11, I get negative 2. Are you done? No, because the answer's got to be a point. You don't know what y is yet. You plug negative 2 into either one of these, and you solve for y. Okay, that should be your little review. That should be very familiar. And the other way, how does elimination work?
We multiply the second equation by 5.
Yeah, you multiply something by something. Let's see.
Yeah, so they cancel out.
Yeah, so see how the x's are already opposite signs. So I would agree. I would multiply the second one by 5, because then these two would cancel when I add them together. Does this sound familiar?
Yeah.
I like it. So then I multiply this by 5, negative 5x plus 10y equals 60, and then I add these together. 11y equals, what did I do? Yeah, that's good. 11y equals, who's this? 55. So y is 5, and if I plug a 5 in for y, I'm going to get x is negative 2. Kick ass. Is that cool? Nathan, is that cool? All right. All right. So you got to remember, there's 3 ways to solve system equations. Graphically, which sometimes sucks, because sometimes the points ain't going to be easy to graph. So thank God we have algebraic ways: substitution, elimination. Yes, sir.
How do you get the 12y and the 60?
Oh, here. Okay, so let me do this a little bit nicer. I was just doing it quickly. What was that? 2y and 12. Okay, so here's what really just happened. I took the second equation and I multiplied it by 5. Bless you. Why did I do that? Because now I'm going to look at the first equation and I add them together. Is anybody ever concerned why you're allowed to add 2 equations together? Yeah. No, I wouldn't say concerned, Jeff. I would just be like, why? Whatever. Right? You're like, another weird shit thing I can do. Yay. Right? But well, what's the only thing you're allowed to do? What do I add to this? I add negative 5 to 60, don't I? Well, am I not supposed to add the same thing to both sides? So really, you should be kind of like, the shit is this? You should add negative 5 to that side. What are you doing? But what is negative 5? Negative 5 is this. So if I add negative 5 to this side and I add this to this side, I am adding the same thing to both sides. That's why it's legal to add equations.
Commutative?
Not really, but it's just adding the same thing to both sides. If I add negative 5 to this side, I better add negative 5, but 5x plus y is negative 5. So I am adding the same thing to both sides. So you should be concerned, why am I allowed to do that shit? I should be able to answer you, or I have to go find another job, which would suck for me. So thankfully I know how to answer that question. Alright, cool. I like it. Good. So you should be concerned. You should ask me, why are you allowed to do that shit? Maybe not like that. But you know, something, just ask me. Alright. And you do this, what do you get when you add these together?
0. 11y.
That looks familiar, right? What we had earlier. So divide by 11, you get y is 5. You plug y back in as 5, and you get x is negative 2. Is that cool? Okay. All right. How we doing? Everybody cool with that?
I got
Yes.
a question on my math lab. I went to my math lab and for the homework for chapter 7, and you don't have it up yet?
Not all of it yet.
Is there going to be like a homework tab? Because I didn't see like a homework tab.
There is. There's like an assignments, I think it says, in the list of things. Yes.
I found the appendix, and it's like 12 problems, but then it walks you through, like identify this number.
So there's your assignments, that the ones that I assigned. That's what you got to do. Yeah. So I think I've only got up through 7.1 up there. I can't remember. But after class, I'm going to put some more up there. Yeah. Cool. Okay. So number 20 also, right? So 20 has got these inequalities in there. Let's first off remember just how to, let's just do one of these. This is one equation they give me, or one inequality. How do I graph that?
You get y by itself
I love it. Why would you get y by itself?
because it's the one.
I know you know. Why is that a good idea from Kiana? Beautiful. So you know what the slope and y-intercept are, the mx plus b. I love it, because the whole idea with this, I don't know if you guys remember this, How do I graph this, for example? How would I graph that? What do I definitely have to have show up here? 4.
It's less than 0.
Less than or equal to 4. So I'm going to shade which way?
Left.
This way.
Yes.
And who remembers what do I put in there?
Lot.
Bracket.
Bracket.
Circle's old news. This crap. This is more. This better. It's more like interval notation. That's why we use it. So what's the whole idea here? I graph the point that divides things in good and evil. No, in answers and not answers. And then I shade the side that is answers, and the other side is not answers. I like it. It's a strict inequality. So only one side is going to work. So here, how many variables do I have? 2. One variable, I'm in 1 dimension. 2 variables, I'm going to be in 2 dimensions. So now, how do you divide 2 dimensions? With a line. So instead of a point being the dividing thing between 2 sides, a line is going to be the dividing thing between 2 sides. Let this make sense. You're just stepping 1 dimension up.
And just bracket because it's solid line. Why is bracket?
Yeah, this is included. So I always say if you want to include it, then you use part of the letter I. Right? If you don't want to include it, remember use an open circle if you don't want to include it. So then we use part of an open circle. We use a parenthesis if you don't want to include it. Very easy to remember. In my brain, I just see that as, well, I'm including this. It's just, and this is like, no. I don't know. That's my own brain. I love that. I love the reaction. That's the correct reaction to have that weird shit, but that's the way I think about it. So how do I solve this for y? The easiest way to do this, by the way, is notice this. The y is negative. So I'm going to add it and subtract the 4. Bam, I'm done. So y will be bigger than or equal to 2x minus 4. So these just kind of switch places. Become a 4. Let me stop there for a second. Is that cool? Or you do it however you want to do it. You just got to remember when you divide by negative, you switch the sign. Okay. How are we doing? We good with that? Do you guys remember that, by the way, while I'm thinking about it? If you divide by negative 1 here, what do you have to do? Why? Why do you do that? Why? Again. If you ever have to find yourself saying, because that's what somebody told me to do, you say, no, me, that ain't good enough. All right? Well, why? Hopefully, did any of my students remember what I showed you? Why did I even do? So here. Which one of these is bigger? 1. If I divide by negative 1, what does that become?
1. Or 2.
2. And what does that become? Which one's bigger?
2.
What happened? Reflection, right? So when you multiply by negative, you change the side that it's on. So why does the sign flip? Because it has to. Nah, I love that. So one time I can answer like that. Because variables are numbers, and numbers act that way, so do variables. Bam, done. I like it. All right, maybe. Okay. So what do I know about this line now? What do I know about that line?
Y-intercept 4.
Yeah, y-intercept is negative 4.
And slope.
Yeah, what's the slope?
Up 2 over 1.
Up 2 over 1. Up 2 over 1. And then what kind of line am I going to make? Now, if that wasn't there, I would have like a open circle kind of idea. So that would be a dashed line that represents non-inclusive. If I see a line, I make a line. It's one of my old students said, Joe, if I see a line, I make it. That's beautiful. I love it. I'm going to steal that. If I see a line, I make a line. If that wasn't there, if it was greater than, I would make it dashed to be sort of like an open, like a parenthesis, like I had up there a second ago. All right, how are we doing so far? Is this? Yes, sir.
Wait, what do you do after? How do you get the middle dot there?
Oh, so what's this tell me?
It's going to be a 2.
2. What's going to be 2?
Slope. 2 over
Slope is 2 over 1, right?
Yeah.
So rise 2, run 1. And negative 4, that's my y-intercept. So start at negative 4, and I rise 2, run 1. Rise 2, run 1.
Oh, okay.
That's why. And how do you check yourself? What point is that?
That's 1 negative 2.
1, negative 2. So when I throw a 1 and a negative 2 in, this should work. In fact, it should be equal to that. All right, so let me stop there for a second. Okay. So you got to remember intercept, slope, That should be easy. I can say that right. If it's not, then you work on it. You come see me, you go see a tutor, you work on it. But that should be the easy part of this. Yes?
Okay, there's a y-intercept which is -4. Why is there a y in the beginning of it? Why did we need the y? Why is the y used as y?
So we have a relationship between y and x, right? So I could say y is twice x plus 1. So any x you give me, I'm going to double it and add 1 to make this new thing y. Is that by itself cool? I mean, that's the whole idea of a relationship between two variables. Is that cool?
No, can you say it again?
So inputs and outputs, right? So if I throw 1 in for x, this tells me what y becomes for that. So this could be a machine where I put some taffy in and it stretches it double to what it was before, and then it adds 1 more foot. So if it was 3 feet, it would come out twice that plus 1. Now it comes out 7 feet long, right? This taffy pulling machine. No, you don't like that either.
No, I understand what you're saying. I just don't understand why is it a y specifically.
Well, it could be anything, to be honest. We just weren't there when they decided, let's make it x and y normally, right? And if you're talking about, it could be t for time, and it could be p for profit. It could be any letter, really. But when there's no true physical meaning, we use x
So
and
it's
y.
the relationship between the y and x-axis.
Yes, the relationship between points on the x-axis and where they get plotted on the y-axis. So, if I'm at 1.
Okay, I don't get it's fine now. Let's move on.
Well, real quick. If I'm at 1 for x, then I would plot it at 3 for y. I mean, that's really the connection between this equation and what it looks like graphically. Now, why is this the y-intercept? Because I get this when I put a 0 in for x. Right, if I put a 0 in for x, I'm going to go only up and down. I'm going to be on the y-axis, so that's why that's the
So it's
y-intercept.
just coincidental that happens to be the y-intercept because it always works.
Yeah, exactly. I mean, I love your question. I want you to understand. I understand your question. I do. But it's because when I make x 0, I get the y-intercept. And when I make x 0, y is b.
Whatever that is.
Exactly. So a bigger question is, why didn't we make the equation? We could have made the equation this. We could solve for x always. And then slope would be run over rise. Hopefully I'm not blowing anybody's brain here a little bit. You're like, oh, stop it, Jeff, just shut up. But I want you to realize a lot of what we do could have been done a different way and would have made just as much sense. It's just that we had to pick a way at some point. So we just chose to do it this way. Thank God this actually makes more sense. Because in real life, I would say that this floor should hopefully have a slope of 0, right? But if we had done it this way, then this would have an infinite slope, this flat thing with the end. So thank God we chose this way. Yeah. Cool. I think that was sort of related to your question.
I think, yeah.
I got you. All right. So coming back here, the one thing we haven't done anything with yet is the fact that this says greater. So this line is where the y's equal this. Cool? So the greater than is just like when I had up here earlier, I got to shade one side or the other. One side is nothing but answers. The other side is nothing but not answers, right? It's like Giants fans and Jets fans or whatever. You normally don't have much overlap there. Right? Some of you guys are like, what is that, hockey? No, come on. So the whole idea here, who remembers how to figure out which side to shade? Yes?
Pick a point on either side of the line and plug it in.
And what point do you almost always try to use?
0,
0, 0. So if I plug the point 0, 0 in, does it work? Is 0 bigger than twice 0 minus 4? Is 0 bigger than -4? Yes. That means that point works. But if that point works, every point on that side works. Because either they all work or they don't. So if that point didn't work, I would have shaded this way. If that point did work, so I shade that way.
So if it works, you shade up.
No. If it works, you shade in the direction of where that point is.
Okay.
So if I plugged that point in and it worked, I would have shaded that way because the point's on that side.
Because it's greater, you shade.
Another way, the way I look at this is, since this is greater than, I shade up.
Okay.
I'm done. Why? Where are the y's bigger than this? Up there. So I would just shade up because it says greater than. up and down get weird, the steeper this gets. That's why that method is not the way I teach it. But that's the way I do it. As long as you know what up and down is from a very steep line, you're okay. All right, how we doing? So very often in this class, if you haven't picked up on this yet, I'm going to give you several different ways to look at a problem. If one of the ways makes no sense, do not feel bad about it. Let it go. You're like, whatever, that's weird. I'm going to do it the way that makes sense. You don't have to know all ways. I do. Right? But you guys don't. Okay. So that problem, though, that was only half of that problem. That problem also said x plus 2y greater than equal to 2. That was the second equation. So all you would do there is you do everything we just did, you would do it for this. Solve for y, graph the line, figure out which side to shade. You just do it on top of the one you already did. And then the answer is going to be where the shading overlaps. I don't know if you guys remember that. Yes?
Always want to do the shading last.
Always want to do the shading last. Yeah, so really here, I tell my students, when you have like 2 of these bad boys to do or more, just put like a couple of little arrows so it doesn't get too spaghetti-ish or, hard to tell what the hell the answer is. So here, just to do this really quickly, you guys got to do this for homework anyway. This would be y greater than equal to ½ x plus 1. The y-shift is 1. I go down 1 over 2. It's going to be a solid line. It's greater than, so I'd shade it up. So the answer would be in there. I know that was quick, and I really don't care. Because the idea, you do the same thing you just did with the other line. You just make it really dark where the shadings overlap. Because what does that mean about this point, right there, that point, whatever point that is? What's true about that point? It works in both inequalities. I love it. Just me.
Where did you get negative 1/2 x?
I wish I knew. So subtract the x, divide by 2. I just solve for y real quick just to get to the point. I know you guys can solve for y. Yes?
Wait, but if you plug in 0 for 0, you'd still...
Yeah, if you plug in, is 0 bigger than 0 plus 1? Is 0 bigger than 1? No, so now I would shade away from that because it didn't work. If it doesn't work, that can't be where the answers are. So for the second guy, did 0, 0 work? No. So then I would shade away from that, right? Because 0, 0 did not work. This side must be where all the not answers are. All right, cool. I like it. Yes, ma'am.
Okay, so I'm going to ask you again, even though he just asked. Where'd you get the negative 1/2 from?
Oh, okay.
I think you have to flip side.
All right.
I think.
So subtract x, then divide by 2. So your y greater equal to negative 1/2 x plus 1. Cool, I like it. So sometimes I'll do that, especially now. I mean, please, if you're worried that I'm going quickly over problems, it's because we're in the review section right now. When we get to new stuff, I'm not going to go this fast over everything. But this is where you desperately have to slow me down like you are right now, which is good. Slow me down with questions, yeah.
It's the shading that I'm confused apart. Do you do only one part of it, or do you do 2 parts of the shading? I'm just confused. Like only the top area?
So for the second guy, you're cool with the first guy we did?
No, the very top one I get.
So this one we did, right?
Yeah, right underneath. So you're saying I need to shade that one darker and shade the other one light?
Yeah, so we did this line totally by itself, and then we shaded this way from that line. Then we did this line on top of it, and we shaded this way from that line.
Right.
Where do the shadings overlap? Here.
Okay, so we only shade that area then.
Yep,
Okay.
I like it. Because this point here would only work in one of them. It wouldn't work in the other one. So I want to darken where they'll work in both. And what do we use this for in the real world? Believe it or not, we do. This could be the safe area. One of these equations could be load on an elevator, and the other one could be, I don't know, number of people so that you don't squeeze each other. So this would be the safe area for how many people you can have in an elevator. Or it could be electrical power so that nothing blows up. So if you're over there like, I think we got to pull back. We're about to blow up. Oh, shit. So this is a way to figure out what's my safe area given some constraints. I don't want to be more than 4 or else my elevator is going to plummet. Well, let's not do that. Let's if I'm out there, let's pull it back. Let's take some people up. I want you guys to realize there is actual physical use of this in the real world. Okay. Let's see. Anything else from? Yes. Oh, sweet. All right. All right, so I feel bad for you if you did this problem and you did 8 times negative 16, because you really made it a lot harder than you had to. I'm sorry. That's all. You only have to do that if you actually cannot take this out. I mean, if I can make this a 1, I totally will. And of course, what number comes out of all 3 of these? 8. So here, since this is an equation, I don't have to take it out. I can just divide by 8. As long as I do it to both sides, I can divide by anything except 0. Some of you guys don't like that, but I don't see why not. I can divide both sides of any equation in the universe by 8. Anytime I want to. Most of the time, it's going to be a dumb thing to do. Why would you do that, Jeff? But here, it's a smart thing to do. Because what happens? That goes away, that goes away, that becomes 2. Yay. So I get z squared plus z minus 2 equals 0. So you cannot, if I said factor this, if I said, I really want to make sure you understand, because some books say, tell me which of these are equations and tell me which of these are expressions. I don't know if you guys have ever remembered seeing that kind of thing. It's because with an equation you can do more than with an expression. I can't get rid of the 8. There's nowhere to put the damn thing. I just have to take it and put it out front. I really want to make that distinction. And then here I can try to factor that, right? But the 8's got to still be there. Here, why am I allowed to kill the 8? Because I got 2 sides. The 0 eats it up. It makes that sound if you get really close. So, what do I do with this now? And what tells me what to do with this? If that wasn't there, all you would do is get the z by itself. You can't get the z's by itself because you can't even put the z's together. So what do you do instead? Factor. Kick ass. And it's already equals 0, thank God. There's only one way to factor 2.
1 and 2.
1 and 2, it's crazy. Now it's just a question of what's what. What's positive, what's negative.
2 negative.
Yeah, bigger one's got to be positive, so it ends up positive 1 at the end. And what's your answer? Z is? Negative 2 makes it 0, so that's an answer, and 1 makes it 0, that's an answer. I like it. Because remember, you could say either this number is 0, or that number is 0. Why is that got to be true? Because this tells me this times that is 0. What's the only way that could happen? If that first one is 0, or the second one is 0.
I missed a step, I'm sorry. It was when you did the z plus 2, z minus 1. The z minus, or plus 2 came from the z minus 2, correct?
No.
Or, okay.
No, definitely not. No.
Explain it again, I missed that.
So how do you factor something like this? We know it came from 2 binomials multiplying together to make this 3-term deal. What multiplies to z squared? Z and z. So now I just need 2 numbers that multiply to be 2 and add to be 1. Right? That's the classic 3-term deal. Yeah, good. That's all I'm doing. Nothing special, nothing new. Just because it's sitting in an equation doesn't make the factoring step different. You still need numbers that multiply to be this, add to be this, because it's 3 terms. The formative.
So the ending answer is just the z plus 2 and the z minus 1?
No. So the instructions on this was solve. So you know you're not done until you know what z has to be.
Got it, okay.
And one possible answer could be no solutions for some of these. Right? Or it could be all real numbers. Sometimes you've seen that. But this one has 2 very specific answers, negative 2 and 1. How do you check it? Well, you just plug it back into the original. Right? Don't plug it back in here because you did something to get there. Maybe the thing you did was wrong. You always plug it back into the original. I like it. Yes, ma'am.
There's problem 40.
Oh, okay. So let me write this. Yeah, I like it. All right, so I realize it's not the problem. So I feel like a politician. Bless you. I hear your question, but let me answer my own question. No. So I'm building up to the actual question. So I don't know if this. I think this is probably the issue is the powers they have. Maybe. So how would I factor this?
Factor out
Yeah, how do you make x squared? XX. Now I just got to figure out the numbers, and of course they would be what? 99. And they both would be negative. So the actual problem, so that's not the problem. The actual problem is this, very, very, very similar, except the powers are a little different, but you do the exact same thing. How do you make x to the fourth? What times itself? And notice something, isn't that what the middle term is? So what's got to be true about this power versus this power? This power has to be half. If that was a 6, this better be a 3, because the first thing you do is you cut it in half to put it there and there. So the only way you can validly factor a trinomial like this is if that middle power is half the first power. We call that quadratic in form. Does it matter if you remember that? No. So if I had a 10 there, this